The first thing you want to start with is, of course, the statements they've given you. Km is congruent to Nm, and we know that because it was given. We also know that Lk is congruent to Ln, also given. With this one, they have a shared side, Lm. So we can say that Lm is congruent to itself. Why can we say that? Reflexive property. And now you'll notice that we have side, side, side. So we can say the two triangles are congruent by that particular theorem. Side, side, side. So you want to start with your givens. Use the definition of something that's in your given if need be. Look for a shared side and then look and see what you have and if you are able to prove it at that point. All right, let's look at the third one. Jm is congruent to Nm. L is the midpoint of Jn. And so again, we're going to start with what they told us. Jm is congruent to Nm, given. Also, L is the midpoint, was also given. And from that, we are going to use what we know about midpoint. If they said that L is the midpoint of Jn, then we know that JL is congruent to NL. And we know that by definition of midpoint. Again, they share a side. So we have Lm is congruent to itself, reflexive. And now we have two sides that were given congruent, two sides that were congruent by bisector, one side that is shared is congruent. So we know that we have three sides congruent. These are congruent by side, side, side. So in this case, if two angles and the included side of one triangle are congruent to two angles and an included side of another triangle, then the two triangles are congruent. So you'll see that we have angle A congruent to angle D, angle B congruent to angle E, and the side in between is. So this is kind of the opposite of side, angle, side. For side, angle, side, we have two sides in the included angle. For angle, side, angle, we have two angles in the included side. All right, and so there are going to be times when you can prove this way versus the other. For this one, SQ bisects RQT and RST. So we have this line segment here that bisects this angle and bisects that angle, all right? They want us to prove that QRS, the top triangle, is congruent to QTS, the bottom triangle. So obviously the first thing we are going to do is we are going to state our given, that SQ bisects those. And then the next two statements have the same exact reason. All right, QS is congruent to QS. Why do we know that one? Why is anything congruent to itself? Reflexive. And so now you'll notice we have an angle and an angle, an angle and an angle, and the included side, the side that's in between those. And so by that we can say angle, side, angle. Angle, side, angle. All right. These sets of lines are what? What does that tell you? What does that symbol tell you? They're parallel. They're parallel. And so you'll notice that I have the parallel marks here. Parallel marks there for those two. Parallel marks here for these. All right, they're parallel. All right, so then the next two angles then, they're telling us they are congruent. So if I have parallel lines, what types of angles are angle JLK and LKM? Yeah, and as same is true for angle MLK and JKL. Those are both alternate interior angles. And so I can say alternate interior angles there. Parallel lines with a transversal, we have alternate interior angles. Alternate interior angles. The next statement is that KL and LK are congruent because they are the same. Anytime something is congruent to itself, it is reflexive. And so now you'll notice we have two angles and the included side. So we have angle, side, angle here. Angle, side, angle. So really, if you have any two angles and a side, you have the proof. You just have to know which one you have. If it is the included side, it needs to be angle, side, angle. If it is not the included side, you have angle, angle, side. This is not true with any two sides and any angle. For two sides, you must have the included angles, side, angle, side. But for angles, if you have any two angles and any side proven, then you actually have the proof. It can be any two angles and a side. You just have to tell me the right one and which one you have. And so in this case, you can have angle A congruent to angle D, angle B congruent to angle E, and BC congruent to EF. Or you could have had AC congruent to DF because you could have gone angle, angle, side the other direction. All right? But once you have that, you have the two triangles are congruent. It is the non-included side. So any two angles on the side, if it is included, it'll be angle, side, angle. If it is not included, it will be angle, angle, side. All right? Either one of those will prove that the triangles are congruent. Either one of those will prove it. And it's basically on the fact that if I have this angle that's here and this angle, so I have two angles, then this line is going to tell me where this angle stops. So of course this would have to meet up. Or this angle, this side would tell me where angle A stops and it would have to meet up there. And so it's just based on how far those angles are going. But you have to have at least two angles. So YZ bisects WYX, and angle W or YWZ is congruent to angle YXZ. All right, so first we have congruent angles. We have YWZ, which is right here. YWZ is congruent to YXZ. YXZ. And so that's the first thing we're going to say are those two statements, is that YZ bisects and that YWZ is congruent to YXZ. And both of those are given. Both of those are given. So then what else do we know? Well, we know the term bisects. And so we're going to use this term right here to figure out some other things, which is two more angles, right? So we have these two angles that are also congruent. So angles WYZ, just follow the line, WYZ is congruent to XYZ because they told us that this guy was the bisector. And so that's definition of a bisector. So you can see that we have two angles. Anytime you have two angles, you need a side, and you can prove it. Well, there's nothing I can do to prove the included side. They haven't given me enough information. I cannot say that WY is congruent to XY. They did not tell me anything that indicates that. However, one of the sides is shared. And so I know if I have a shared side, I have a congruent side because anything is congruent to itself. So I can say that YZ is congruent to itself, that shared side, because of the reflexive property. And now I have two angles and a side. This particular side is not included, so I know the triangles are congruent, angle, angle, side, because the side is not in between the two angles. Let's look at this one. The first three statements are easy. They gave me three statements, so I use those as my given. Two of those statements are going to help me moving forward. So I have parallel lines and I have midpoint. All right? Parallel lines. Anytime you have parallel lines, you're going to look for types of angles. All right. In this case, if these are parallel lines, and so I am going to take this, and maybe I'll extend it out so that I can see kind of what I'm looking at here. I have parallel lines, and then I have this transversal that goes through it. All right. And so I don't have alternate interior angles because I would have to use one out here and one in here, right? Or something like this. But I do have potentially corresponding angles. Everybody see that? Right? I have corresponding angles. Angle BAC and ECD are corresponding angles. So what do I know about them? They're congruent, all right? And so I can see then that angle BAC is congruent to ECD. And I know that because corresponding angles are congruent. Corresponding angles are congruent. So anytime you have parallel lines, you're likely going to look for alternate interior, alternate exterior, or corresponding angles. Parallel lines are trying to tell you an angle relationship that are congruent. All right? And so we definitely have corresponding angles there. Corresponding angles. And even if you have to extend the line so that you can see that you have corresponding angles, you can do that. All right? The next thing is the word midpoint. So the word midpoint helps me because I know that midpoint tells me something. All right, what does midpoint tell me? In this particular case, C is the midpoint of AD. So what does that tell me about these two lines? They're congruent, right? So I'm going to say that AC then is congruent to CD. And why do I know that? Definition of midpoint. And now I have angle, and a side. Angle, angle, and a side. So I can say that the two triangles are congruent by angle, angle, side. If the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. All right, so in this case, just to recall, my hypotenuse is the side opposite my right angle. It is the longest side. All right. And so hypotenuse leg only works for a right triangle. It doesn't work for any other triangle. If I have the hypotenuse congruent and either leg congruent, then I have a congruent right triangle. And so if I have the hypotenuse congruent, one of the legs congruent, I can say that the triangle itself is congruent. The triangle itself is congruent. The hypotenuse, they're reminding you here, is the side opposite the right triangle. The leg is the side adjacent to the right triangle. So either leg and hypotenuse, you have a hypotenuse leg proof. Only true for right triangles. So somewhere in the proof, they had to either tell you you had right triangles, or they could have used the term perpendicular to tell you you had right angles. And then you can say, I have a right angle by definition of perpendicular. I have a right triangle by definition of a right triangle. All right, but somewhere they have to tell you that you have a right triangle by some method of telling you that. And very often they'll just say it. So let's look at this first proof here. Number 1. Given that triangle LMP and MNP are right triangles, and that ML is congruent to MN, all right? And so the first one's simple. They told us that those are right triangles. They told us that those sides were congruent. So first of all, what side did they tell us? Well, they told us ML and MN. That is the hypotenuse. So now I know if I have a right triangle, I just need to prove one other side. I have the hypotenuse, just one other side will work. All right? And so they have a shared side, which is MP. Anytime it's shared, it's going to be the reflexive property. And so I know that by hypotenuse leg, I have this particular proof. Hypotenuse leg, I have this particular proof. Only works for right triangles. Only works for right triangles. Right? So go ahead and try number 2 there. We're going to start with our given. And they've actually given us 3 statements. They've said that we have right triangles, one of the sides is congruent, and x is the midpoint. And so those 3 statements are all given. All right, and marking it helps. And so we have right triangles here. We know that V and Z, based on this, is what we have as the right triangles here. I've marked my WV as well, WV and YZ. And then the next thing that we can look at is the word midpoint. The word midpoint is going to give us these 2. So x is the midpoint of this, is going to give us these 2 right here. And so by definition of midpoint, we can say that those 2 sides as well. These sides are the hypotenuse of those. This is the leg. And so we can go straight to the 2 triangles being congruent by hypotenuse leg. Hypotenuse leg. And so when it tells you then, I want you to prove that a piece of the triangle is congruent, this is when you're going to use this particular theorem here, that congruent parts of congruent triangles are congruent. You're going to have to prove the 2 triangles are congruent first by one of those 4 methods, 5 potentially if it's a right triangle. And then after you prove that the 2 triangles are congruent, you can go straight to that any piece is congruent because of this. Congruent, our corresponding parts of congruent triangles are congruent. So CPCTC is what you can just put as your reason. You don't have to write it all out, but you do have to know what it means. It means corresponding parts of congruent triangles are congruent. And so you're going to use this when they say, hey, prove that angle A is congruent to angle D. In order to do that, you have to prove the triangles are congruent first. Proving a side is congruent to a side means that you have to prove that the triangles are congruent first. And so to use this theorem, when you're asked to prove parts are congruent, first you have to prove that the triangles are congruent. And so you're going to use one of the methods that we've talked about so far to prove the triangles are congruent, and then from there you can then prove that the sides or angles of the triangles are congruent. This is what you're going to see that's going to clue you in that you're going to use this particular theorem, this corresponding parts, okay? When they have given you information with 2 triangles and then they want you to prove that a piece is congruent, in this case they've given us sides are congruent, and then they say prove that angle BCA is congruent to angle DCA. You know that you're going to have to prove the triangles congruent first, and then as soon as you prove the triangles are congruent, you can move right to that piece being congruent because it's corresponding. All right, so anytime you see this, you know your very last statement is going to be that corresponding parts. That's what it's going to be. And you just have to figure out which of those methods you're going to use to prove those triangles. So the first thing you want to do is use your given. They've given us that AB is congruent to AD. And so you want to mark that on your picture there. AB is congruent to AD. They have also told us that BC is congruent to DC. You want to mark that as well. All right? And we know both of those because they are given. In this case, I have 2 sides. There is nothing that's going to help me get that interior angle. So side angle side is pretty much off the table. If they had said this bisects an angle or something like that, then I might be moving towards a side angle side. But they didn't tell me that. What I do know is they have a shared side. And so that shared side is the 3rd side that I need here. And so I can say this 3rd side, well, that's congruent to itself by reflexive. So now I have side, 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 which tells me the triangles are congruent. And so when I have one where I'm trying to prove a part, I am going to look and see which method can I prove that the two triangles are congruent. In this case, side, side, side. Once I have that the triangles are congruent by one of those methods, I can jump straight to what I'm trying to prove, which is that these angles are congruent. Angle BCA is congruent to angle DCA. I'm trying to prove that those angles are congruent. And once I have the triangles are congruent, I can say, yeah, those angles are congruent because corresponding parts of congruent triangles are congruent. And so anytime they want you to prove a piece, you're going to prove the triangle's congruent first, and then you're going to jump right to this corresponding parts theorem. So go ahead and do number 2. What am I going to start with? Always. My given, right? So they've told us that PS is parallel to QR. They've told us that angle QPS is congruent to angle SRQ. And you want to mark those as well. So you want to mark your parallel. And then you want to mark your congruence. All right. So the parallel lines are going to tell us something. I have parallel lines here and a transversal here. All right. And so either one of these actually are alternate interior. In this case, they did that one. All right. Those angles are congruent because of alternate interior. So I have 2 angles. So I either need the included side. Nothing tells me the included side is going to help. The not included side is shared. So I know that a shared side is congruent to itself by reflexive. So I have angle, angle, side. I have just proven that my triangles are congruent by angle, angle, side. Angle, angle, side, my triangles are congruent. They want me to prove that a piece of the triangles is congruent. PQ, line segment PQ is congruent to line segment RS. So they're trying to prove that line segment PQ is congruent to RS. Once I have proven that the triangles are congruent, I can say that those sides are congruent by my corresponding parts of congruent triangles are congruent. So anytime you have these pieces, you're going to prove the triangle first by one of those methods.